Welcome to Rose Project for 11th Standard conducted by Yashwantrao Chavan Institute of Science, Satara. I am Mujawar. Yes. In this lecture, we will discuss the matrices. In previous lectures, we have seen the determinant. Now we will see the points in some points in matrix. So this is first lecture for matrix. In this lecture, we will see definition of matrix, order of a matrix, types of matrices, and examples. So definition, it is an arrangement of mn elements in m rows and in n columns enclosed between square or round brackets. It is an arrangement of mn elements in m rows and in n columns enclosed between a square or round bracket. Matrices are generally denoted by capital alphabets A, B, C, D up to Z. Elements of matrices are denoted by small letters A, B, C, D up to X, Y, Z. So this is the example of a matrix. So there are 9 elements arranged in 3 rows and 3 columns. So this is matrix A of order 3 by 3. A with the matrix of order 3 by 3. So order order of a matrix can be written as m by n. So first number represent number of rows of matrix A, and second number represents number of columns of matrix A. So this matrix A has 3 rows. So first number is 3 by or into it has 3 columns. So second number is 3. So B with the matrix of order 2 by 2. It has 2 rows and 2 columns. So B with the matrix of order 2 by 2. Now C with the matrix. So this is arrangement of 12 elements in 3 rows and 4 columns. So C has the order number of rows first 3 and number of columns 4. The नेहमीच number of rows पहिल्यांदा लिहिले जातात into number of columns. इथे 3 rows आहेत 4 columns आहेत, so 3 by 4. A capital A is equal to A as A m cross n. So this is a general matrix of order m by n and elements with its position. So 1 1 A11 means element in first row and in first column. A12 element in first row and in second column. A1n element in first row and nth column. Similarly, other elements are there, and this is the last row AM1, AM2, AM3 up to AMN. So this is first number represent row number 1, 2, 3. So this is m row. This matrix has total m rows, and second number denote columns 1, 2, 3 up to n. So it has n columns. So order of this matrix is m by n. Similarly, we have 3 by 3 square matrix of order 3. So this is the matrix of order 3 by 3 with elements with its position. And B be the matrix of order 2 by 2. Now types of matrices. So there are several types of matrices. Now first, row matrix. A matrix having only one row is called as a row matrix. So this is the matrix. It has only one row and 2 columns. So its order is 1 by 2. So B be the matrix. It has only one row and 4 columns. Its order is 1 by 4. So this is also row matrix. C be the matrix, row matrix, because it has only one row and 3 columns. Here we can see the first number from the order is always 1 for row matrix. So in general, row matrix has order 1 by n. Row matrix मध्ये एकच रो असतो, त्यामुळे जनरली रो मॅट्रिक्स ऑर्डर नेहमी 1 by n मध्येच असेल, कारण 1 रो आणि कॉलम किती असतील. सेकंड टाइप, कॉलम मॅट्रिक्स. A matrix having only one column is called as a column matrix. ज्या मॅट्रिक्स मध्ये फक्त एकच कॉलम असतो त्याला कॉलम मॅट्रिक्स म्हणतात. So R057, this is column matrix. It has only one column, 3 rows. So 3 by 1 is its order. P, so this is 2 by 1, 2 rows and 1 column. Q, it has 4 rows and 1 column. So order is 4 by 1. So in general, column matrix has order m by 1, where m greater than or equal to 1. So in general, column matrix has order m by 1. Single element matrix is row matrix as well as column matrix. ज्या matrix मध्ये एकच element असेल म्हणजे त्याचा row पण एक आणि column पण एक. So this is single element matrix. It has order 1 by 1 and it is both a row matrix as well as column matrix. Zero or null matrix. A matrix in which every element is zero is called zero matrix. ज्या matrix मधले सर्व element zero असतात त्याला zero matrix. It is denoted by 0. So this is the zero matrix of order 3 by 3. All the elements are 0. So this one is also zero matrix of order 3 by 2. And this is zero matrix of order 2 by 3. Elements are 0. Now fourth, square matrix. A matrix with equal number of rows and columns is called a square matrix. If your matrix has number of rows and number of columns are equal, then it is square matrix. So Z be the square matrix. It has 3 rows and 3 columns. So X is 2 by 2 matrix, same number of rows and columns. So it is square matrix. And now matrix of order n by n is also called as square matrix of order n. Matrix of order 2 by 2 is also called as square matrix of order n. Now let A is equal to AI is n cross n be a square matrix of order n. Then consider for reference this matrix capital A with 9 elements with its suffixes denotes its position. Now first, the elements A11, A22, A33, AII up to ANN are called the diagonal elements of matrix A. So all these are diagonal elements A11, A22, A33. So these are the diagonal elements. Now elements Aij where I not equal to j are called non-diagonal elements of matrix A. Those elements whose I not equal to j. So here A12, A13, 23, A21, A31, A32. Here I not equal to j. So these are non-diagonal elements. So there are 6 non-diagonal elements for this matrix. Elements Aij where I less than j represents elements above the diagonal. So let me show here. So these are the elements in which second suffix is greater than first suffix. Second suffix 3 greater than 1, 2 greater than 1, 3 greater than 2. So these are elements above the diagonal. Elements Aij where I greater than j represents elements below the diagonal. When I greater than j, then elements. So these are the elements between the two lines. Here we can see first suffix 2 greater than 1, 3 greater than 1, and this 3 greater than 2. I greater than j. Therefore, all these elements are below the diagonal. The diagonal elements are defined only for a square matrix. So diagonal elements are defined only for square matrix, not for all matrices. Now, diagonal matrix. A square matrix in which every non-diagonal element is 0 is called a diagonal matrix. मॅट्रिक्स स्क्वेअर मॅट्रिक्स पाहिजे आणि त्याचे सर्व नॉन डायगोनल एलिमेंट्स 0 पाहिजेत त्याला म्हणायचं डायगोनल मॅट्रिक्स. सो Z is a diagonal matrix because all its non-diagonal elements are 0. X is also diagonal matrix. All its non-diagonal elements are 0. Some of the diagonal elements may be 0. So Y is again diagonal matrix because all its non-diagonal elements are 0. Next, scalar matrix. A diagonal matrix in which all the diagonal elements are same is called as a scalar matrix. A diagonal matrix म्हणजे स्केलर मॅट्रिक्स हा पहिल्यांदा डायगोनल मॅट्रिक्स पाहिजे आणि त्याच्यामध्ये डायगोनल एलिमेंट सगळे सेम असतील. So this is a scalar matrix. It is diagonal matrix in which all the diagonal elements are same, that is 4. So this is scalar matrix. Again, so this is diagonal matrix. X be the diagonal matrix of order 2 by 2 and all its diagonal elements are same. Now, unit or identity matrix, 7th type, unit or identity matrix. A scalar matrix in which all the diagonal elements are 1, that is unity, is called unit matrix or an identity matrix. A scalar matrix in which all the diagonal elements are unity or 1 is called unit matrix or an identity matrix. Now this is I be the identity matrix. This is of order 3 by 3 and this is scalar matrix. All the elements, diagonal elements are same, but the matrix to be unit matrix, all the diagonal elements must be equal to 1 or unity. So this is identity matrix of order 3. So this is the identity matrix of order 2. All its diagonal elements are same, that is 1. An identity matrix of order n is denoted by In. Sometimes In is identity matrix of order n. So this is very important type of matrix, identity matrix. Now, upper triangular matrix, a square matrix in which every element below the diagonal is 0, is called an upper triangular matrix. A square matrix in which every element below the diagonal is 0. So here, this is square matrix and every element below this diagonal are 0. We can see all these elements below the diagonal are 0. Now second, so this is X be the matrix of order 2 by 2 and all its element below the diagonal are 0. It has only one below diagonal element which is 0. Now lower triangular, opposite to upper triangular, there is lower triangular matrix. We have the definition, a square matrix in which every element above the diagonal is 0 is called a lower triangular matrix. So every element above the diagonal must be equal to 0. We have the example Z. And in this example, we can see that all the element above the diagonal are 0. So these three elements are 0. So this is lower triangular matrix. Again, X be the matrix, all the element above the diagonal are 0. Next type. Now, determinant of a matrix. How to find determinant of matrix and for what type of matrices its determinant exists. So determinant of a matrix is defined only for a square matrix. As we know, the determinant is always of square order, 2 by 2, 1 by 1, 2 by 2, 3 by 3, 4 by 4. So finding the determinant of a matrix, so matrix should be of square order or square matrix. Now A be the matrix 3 by 3, its order 3 by 3. So its determinant is defined by, so putting two vertical line on either side of this capital letter A and this square bracket replaced by two vertical lines. So this is determinant of matrix A. Now X be the matrix of order 2 by 2. Now its determinant value or determinant of this matrix X is determinant of X and this square bracket replaced by two vertical bar or two vertical lines. So matrix and determinant have differences. 10. Now 10th type of a matrix, singular matrix. A square matrix A is said to be singular matrix if its determinant value is equal to 0. Otherwise, it is said to be non-singular matrix. If we find square matrix. If we find the determinant of square matrix and its determinant value is 0, then it is singular matrix. Consider example, X be the matrix containing 4 elements of order 2 by 2. Now we find determinant value and we expand 8 into 3, 24 minus 6 into 4, 24, 24 minus 24, 0. So its determinant value is 0. So therefore it is a singular matrix. So X is singular matrix. Now another, we have 3 by 3 matrix, square matrix of order 3. Now we can check whether it is singular or non-singular by calculating its determinant value. Now expanding this determinant, we have 24 minus 2 into 24 minus 25 minus 3. Here 18 minus 20 plus 4, 15 minus 16. So 24 minus 25 minus 1, 2 into minus 1, minus 3 into minus 2, 4 into minus 1. And this is minus 2 plus 6 minus 4, that is 0. So A is a singular matrix. Its determinant value is 0. That's why it is singular matrix. Now 11th type, non-singular, opposite to singular matrix. A square matrix A is said to be a non-singular matrix if determinant of A not equal to 0. If its determinant value is different from 0, then matrix is non-singular matrix. So we have C be the matrix of order 3 by 3. Now we find its determinant value. So by expanding this determinant, as we seen in determinant, so this is the expansion of determinant. तुम्हाला माहितच आहे की कसं determinant expand करतात ते पुन्हा मी इथे explain करत नाही. So this is 46, which is not equal to 0. So C is a non-singular matrix. So this matrix C is non-singular because its determinant value is different from 0. Now we have the 12th type, symmetric matrix. A square matrix A, Aij of order n by n, in which Aij is equal to Aji for all I and j is called a symmetric matrix. A square matrix in which Aij is equal to Aji for all I and j is called a symmetric matrix. So we have DB the square matrix, and we can see that here A12 is same as A21. Let me show you here. A12 is same as A21. A13 is same as A31. A23 is same as A32. So this matrix is symmetric about its diagonal. हा मॅट्रिक्स त्याच्या डायगोनलच्या भोवती सिमेट्रिक आहे. म्हणजे जर ह्या डायगोनलवर घडी काढली की हे एलिमेंट तंतोतंत जुळतील. Again X, this is also symmetric matrix because A12 and A21 are same. C be the again symmetric matrix because it is symmetric about its diagonal. So here A12 6, here 6, A13 minus 9, A31 minus 9, A23 minus 3, A32 minus 3. So this one is symmetric matrix. Now the scalar matrices are symmetric. A null square matrix is also symmetric. As we know that scalar matrices, in scalar matrix all the non-diagonal elements are 0. So automatically they are symmetric. Aij is equal to Aj, and null square matrix is also symmetric because all the elements are 0. Now skew symmetric matrix. So there is little bit difference between symmetric and skew symmetric. A square matrix A is equal to Aij of order n by n, in which Aij is equal to minus Aji for all I and j is called a skew symmetric matrix. So Aij is equal to minus Aji. So one is negative of other. So here for I is equal to j, Aij is equal to minus Aji. If I is equal to j, so j is replaced by I. So Aii is equal to minus 2 Aii. So 2 Aii is equal to 0. ai is equal to 0 for all I values of I 1, 2, 3 up to n. So here we have seen the diagonal elements are 0 for skew symmetric matrix. In skew symmetric matrix, each diagonal element is 0. Consider, so we have the example here, A be the matrix. Here A12 is 2, but A21 is -2. So there is difference between sign only. So here -5 and here 5, here 8, A23 at position A23 and A32 -8. So difference in sign only. So this is 2 by 2 matrix. All the diagonal elements are 0. And here A12 is -2 and A21 is 2. A null square matrix is also a skew symmetric matrix. A null square matrix is also a skew symmetric matrix. Square matrix in which all the elements are 0 is skew symmetric matrix because all its diagonal elements are 0 and non-diagonal elements are also 0. Now, transpose of a matrix. So we have seen there are 13 types of matrices. First one is row matrix, second one is column matrix, third one is square matrix, zero matrix, and after that all the definitions are depends on square matrices. So the matrix to be scalar matrix, diagonal matrix, or scalar matrix, symmetric, skew symmetric, singular, non-singular, that matrix must be of square order. तर ह्या पहिल्या 3 टाइप्स सोडले की पुढचे सगळे टाइप स्क्वेअर मॅट्रिक्स वर डिपेंड आहेत. तो स्क्यू सिमेट्रिक असण्यासाठी स्क्वेअर असायला पाहिजे, तो सिंग्युलर नॉन सिंग्युलर असण्यासाठी सुद्धा तो स्क्वेअर असायला पाहिजे. ठीक आहे. सो ट्रान्सपोज ऑफ ए मॅट्रिक्स. Transpose of a matrix A is obtained by converting rows into columns or columns into rows. It is denoted by A transpose. So transpose of a matrix is obtained by converting rows into columns and columns into rows. त्या मॅट्रिक्सच्या रोचे कॉलम करायचे आणि कॉलमचे रोज करायचे म्हणजे त्या मॅट्रिक्सचं ट्रान्सपोज भेटतो. इट इज डिनोटेड बाय ए ट्रान्सपोज. सो देयर इज upper suffix on capital letter A. So here A be the matrix of order m by n, then A transpose has the order n by n. ट्रान्सपोज घेतल्यानंतर रो चे कॉलम होतात आणि कॉलमचे रो होतात, त्यामुळे त्या मॅट्रिक्सची ऑर्डर चेंज होते, m by n ची n by m होते. If A is equal to this matrix of order 3 by 2, now we take its transpose. So then A transpose is, so this first row, first column becomes first row, and this second column becomes its second row. So this is transpose of given matrix. Now आपण रो चे कॉलम केले तर आपोआपच कॉलमचे रोज केले तर आपोआपच रो चे कॉलम झालेले आहेत. -1 इथं पहिला कॉलम झालेला आहे, 3 - 2 हा दुसरा रो आहे, तो दुसरा कॉलम झालेला आहे. 3 by 2 चे ऑर्डर इथं काय झालेलं आहे, 2 by 3. If C be the matrix of order 3 by 3, then it's transpose, that is first column 3 1 2 becomes here first row 3 1 2, -4 1 3 becomes -4 1 3 second row, third column 5 - 2 1 becomes 5 - 2 1 third row. So if the matrix is square matrix, then its order will not change. Both the numbers are same. So 3 by 3 is same as 3 by 3. So C and C transpose have the same order. Now remark, if A is symmetric matrix, then A is equal to A transpose. If the given matrix is symmetric, then all its elements are symmetric and diagonal elements does not change its position. So for the matrix is symmetric, its transpose and matrix itself are equal. If A is skew symmetric, then A transpose is equal to -A. If matrix is skew symmetric, then its transpose is equal to -A. Now we will see some example. Construct a matrix A is equal to Aij of order 3 by 2, whose elements Aij are given by Aij is equal to I minus 3j. So we have to construct matrix capital A, Aij of order 3 by 2, means it has 6 elements, and each element is given by the formula Aij is equal to I minus 3j. There is condition on suffixes of on Aij. Now solution. So there are 6 elements. So I can take value. Its order is 3 by 2. So there must be 3 rows. So I can take value 1, 2, 3, and j can take value 1, 2, because j can take maximum value 2. So 1, 2. Now we put different values and we will find the 6 elements. We are given by A is equal to I minus 3j. A1, 1. So here I replaced by 1 and j replaced by 1. So 1 minus 3 into 1, that is minus 2. A1, 2. Again here I minus 3 into 2. 1 minus 6, that is minus 5. A2, 1. I replaced by 2 and j replaced by here 1. So 2 minus 3 minus 1. A2, 2. So 2 minus 3 into 2, 6. 2 minus 6 minus 4. A3, 1. 3 minus 3 is 0. And here A3, 2. 3 minus 3 into 2. 3 minus 6 minus 3. So we have got all the 6 elements by using this formula. So this is the matrix A, minus with first row minus 2 minus 5, second row minus 1 minus 4, and third row 0 minus 3. So this is the matrix. Now again, second example, construct a matrix A is equal to Aij of order 3 by 2 whose elements Aij are given by. So again, elements of this matrix is given by the formula A is equal to I minus j bracket square upon 5 minus I. So we put different values of I and j and we can calculate the elements of matrix. So order of matrix is 3 by 2. So it has 6 elements. So I can take value from 1, 2, 3. And there are only 2 columns. So j suffix can take value 1 and 2 only. So we are given by the formula for Aij, I minus j bracket square upon 5 minus I. So for A1, 1, we replace I by 1 and j by 1 in this formula, and this is I also by 1. So 1 minus 1, 0 bracket square upon 5 minus 1, that is 4. 0 upon 4 is 0. A1, 2. So this is 1 minus 2 bracket square upon 5 minus 1. So 1 minus 2 minus 1 square upon 5 minus 1, 4. So this is 1 by 4. A2, 1. So here 2 minus 1. 2 minus 1 bracket square upon 5 minus 2. So 1 square upon 3 is equal to 1 by 3. A2, 2. So here I replace by 2, j replace by 2. 2 minus 2 bracket square upon 5 minus 2, 0 upon 3, that is 0. A3, 1. Again here 3 minus 1 bracket square upon 5 minus 3. So 2 square upon 2, that is 2. And A3, 2. 3 minus 2 bracket square upon 5 minus 3. So 1 by 2. So we have this matrix 0, 1 by 4, 1 by 3, 0, 2, 1 by 2. Now we have the example. Classify the following matrices as a row, column, square, diagonal, and upper triangular, lower triangular, a symmetric or skew symmetric matrix. So we have to classify given matrices in these types. So we have to write the type of given matrix. So एकाच मॅट्रिक्सचे आपण 2-3 टाइप मध्ये त्याचं नाव लिहू शकतो. आता याला सुरुवातीला आपण स्क्वेअर मॅट्रिक्स सुद्धा म्हणू शकतो, कारण नंबर ऑफ रो नंबर ऑफ कॉलम्स समान आहेत. पण पर्टिक्युलर नेम म्हटलं तर हे अप्पर ट्रायंग्युलर मॅट्रिक्स आहे. इट्स सोल्युशन इज अप्पर ट्रायंग्युलर मॅट्रिक्स बिकॉज ऑल इट्स elements below the diagonal are 0. Now second, so this is all the diagonal elements are 0. It's square matrix, all the diagonal elements are 0, and remaining elements are negative of each other. So this is a skew symmetric matrix. Third, so all the elements above the diagonal are 0. So this is lower triangular matrix. Now this matrix has only one column, so this is a column matrix. So fifth example, here we can see all the non-diagonal elements are 0. All the non-diagonal elements are 0, and all the diagonal elements are not same. So it is only diagonal matrix. This matrix is also upper triangular, lower triangular also. So we can say this is upper triangular, lower triangular, and diagonal matrix. So sixth, again, Aij is equal to minus Aij equal to Aji. So these elements are symmetric about the diagonal. So this is symmetric matrix. Now seventh example, here it is square matrix, diagonal elements are same, and unity, non-diagonal elements are 0. So this is unit matrix or identity matrix. Eighth example, last example, this matrix is square matrix. Again, we can say this is diagonal matrix. This one is upper triangular, lower triangular, but particularly it is scalar matrix, diagonal matrix in which all the diagonal elements are same. So this is a scalar matrix. Now, which of the following matrices are singular or non-singular? So we have to find given matrix is singular or non-singular. Solution, we know that we have studied that the matrix is singular if its determinant value is 0, and it is not non-singular if its determinant value is different from 0. So its determinant value 7, 5 minus 4, 7. So 49 minus of minus 20, so 69, which is not equal to 0. So this is A is non-singular matrix. Now another example of matrix of order 3 by 3. Now it has larger element, मोठे numbers आहेत. न expand करता आपण properties of determinant use करून सुद्धा expand करू शकतो आणि value काढू शकतो. So B be the matrix. Now its determinant value. If we add this first column to this second column, then 5 plus 0, 5, 1 plus 99, 100, and 6 plus 99, 105. So here C2 and C3 will be equal, and any determinant has 2 rows or 2 columns are identical, then the value of determinant is 0. So here we use a column transformation, that we add C1 to C2. We add this C1 column to C2. So therefore, the determinant will be, that is here, this second column and third column are equal. Therefore, its value is 0. So therefore, B is a singular matrix. B is a singular matrix. Now, find K if the following matrices are singular. We are given that this matrix is singular. Solution, let A be the given matrix. A is singular matrix, therefore its determinant value is 0. Therefore, determinant of this matrix is equal to 0. So 7k minus of minus 6 is equal to 0. 7k plus 6 is equal to 0. So k is equal to minus 6 by 7. Now second example, we have 3 rows and 3 columns. We are given this matrix is singular and we have to find the value of k. Let B k minus 1, 2, 3, 3, 1, 2, 1 minus 2, 4. B is singular matrix, that's why its determinant value is 0. So its determinant value is equal to 0. Now expanding this determinant, k minus 1, 4 minus of minus plus 4 minus 2, 12 minus 2, and here 3 minus 6 minus 1. So 8 into k minus 1 minus 2 into 10 and 3 into minus 7. So 8k minus 8 plus minus 20 minus 21. So 8k minus 49. So k is equal to 49 by 8. Now we have the example, find ABC if the matrix is symmetric. So this matrix is symmetric and we know that all those non-diagonal elements are symmetric about the diagonal. For symmetric matrix, Aij is equal to Aji. So A12 is same as A21. So A21 is equal to A12, A13 is equal to A31, and A32 is equal to A23. So B is equal to 3 by 5. Here these elements are equal for matrix to be symmetric. A is equal to minus 4. Here A is equal to this minus 4. And A32, that is C, is equal to this minus 7. Now again we have example for each of the following matrices using its transpose state whether it is symmetric or skew symmetric. Now we know that if its transpose is equal to its matrix itself, then matrix is singular symmetric, and if its transpose is equal to negative of the given matrix, then it is skew symmetric matrix. Consider the example. This is matrix of order 3 by 3. Let B is equal to this matrix. Now B transpose here, first row becomes first column, second row becomes second column, third row becomes third column. So B transpose is equal to B. So its transpose and given matrix are equal. So this is symmetric matrix. Now again we have second example containing the iota, that is root -1. Solution, let C is equal to, so this is 3 by 3 matrix. Now we take its transpose. So first column becomes first row here, second column becomes second row, and third column becomes third row. Okay. Now C transpose equal to, now if we take minus sign common from each and every element of this C transpose, then sign will change inside the matrix. So this is 1 plus 2i, 2 minus I, that is I minus 2. So this is a minus sign as it is, and this is the matrix, given matrix C. So C transpose equal to minus C. So this is, C is skew symmetric matrix, and we know that its diagonal elements are 0. So it is skew symmetric matrix. So thank you all of you. So we shall stop here.